You flip a switch, light floods the room. You don't think twice about it. Why would you? It's electricity. You've been using it your entire life. Every device in your hand, every screen you stare at, every wire running through the walls around you right now, all of it powered by the same force. You think you understand it. Everyone does. We learned about it in school. Electrons, current, voltage. Simple enough, right? But here's what Richard Feynman, one of the greatest physicists who ever lived, discovered when he tried to actually explain electricity to his students at Caltech. He couldn't. Not in the way we're told it works. And the more he dug into it, the more he realized we've been teaching people a convenient lie. A story that makes sense on the surface, but completely falls apart the moment you ask the most basic question of all. What is electricity actually? Not the word, not the definition you memorized. What is it? Because once you see what Feynman saw, once you understand what's really happening when you flip that switch, you'll realize something deeply unsettling. We're not using technology. We're manipulating a force so fundamental, so bizarre, that even the smartest physicists in history couldn't figure out where it comes from. And we do it billions of times a day without a second thought. Let me ask you something. When you plug in your phone charger, where does the power come from? The wall socket, obviously. But where does it come from before that? The power plant, sure. Burning coal or spinning turbines or splitting atoms somewhere far away. But that's still not the answer. That's like saying your car runs because you press the gas pedal. It's technically true, but it explains nothing about what's actually happening under the hood. Here's what we're taught. Electricity is electrons flowing through wires. A current, like water through a pipe. The power plant pushes electrons into the grid. They flow through the wires, into your house, through your charger, and into your phone. Done. Makes sense. Except it's wrong. Not technically wrong, but wrong in every way that matters. Because electrons barely move. They drift through copper wire at about 1 millimeter per second. 1 millimeter per second. That's slower than a snail, slower than grass grows. So when you flip a light switch and the bulb turns on instantly, those electrons didn't just sprint from the power plant to your ceiling in a fraction of a second. That's physically impossible. So what did? The electromagnetic field. Not the electrons, the field. And here's where everything we think we know starts to collapse. Because nobody, not even Feynman, could tell you what an electromagnetic field actually is. They can tell you what it does. They can write equations that predict its behavior with terrifying accuracy. But what it is, what this invisible thing filling all of space actually is made of, nobody knows. Feynman himself admitted this in his lectures. He said, "We teach students about electric and magnetic fields as if they're real, tangible things, but we have no idea what they're made of. No idea why they exist. No idea how something with no mass, no substance, no physical form can carry energy across empty space and make electrons move. We just know it does. And we've built our entire civilization on top of that mystery." Think about that light switch again. When you flip it, what happens? An electromagnetic field, this invisible, unexplainable thing, propagates outward from the switch at the speed of light. Not the electrons. The field. It travels down the wire at 299,792,458 meters per second, reaches the light bulb, and causes the electrons in the filament to start vibrating. Those electrons had been sitting there the whole time. They didn't come from anywhere. The field just reached them and made them move. And when they move, they heat up. And when they heat up, they glow. That's your light. But what made the field? What is the field? How does something with no substance carry energy? These are the questions that haunted Feynman. These are the questions that have never been answered. Yet you flip that switch every single day. Let's go deeper. Let's talk about what holds an electron together. You've heard of electrons, obviously. Tiny particles with negative charge. They orbit atoms. They flow through wires. Basic stuff. But here's something they don't mention in high school physics. An electron is a problem. A fundamental, unsolved problem in physics that has existed for over a century. Because if an electron is a particle, a little ball of negative charge, then every part of that ball should be pushing away from every other part. Negative charges repel each other, right? That's basic. So why doesn't the electron explode? What's holding it together? Feynman asked this question in his famous lectures. He said, maybe the electron isn't a ball at all, maybe it's a point. A mathematical point with zero size, zero volume, just pure charge, concentrated at a single location in space. That would solve the self-repulsion problem. Points don't have parts, so they can't push themselves apart. Problem solved, except it creates a worse problem. If an electron is a point, if it has zero size, then all of its charge is concentrated in zero space. The electric field at the location of the electron becomes infinite, literally infinite. The math breaks. The equations explode into nonsense, and when Feynman tried to calculate the energy of that infinite field, he got an answer of infinite energy. An electron with infinite energy, which is obviously impossible. So what do physicists do? They use something called renormalization, a mathematical trick. They say, okay, the energy is infinite, but we can subtract infinity from infinity and get a finite answer, which sounds insane because it is insane. It's like saying 1 divided by 0 equals 17 if you squint hard enough, but it works. It makes predictions that match reality with unbelievable precision. Quantum electrodynamics, the theory built on this absurd mathematical trick, is the most accurate scientific theory ever created. It can predict the behavior of electrons to 14 decimal places. 14! That's like predicting the distance from New York to Los Angeles to within the width of a human hair. And it's all built on subtracting infinity from infinity. Feynman won the Nobel Prize for developing this theory. He also said it was intellectually embarrassing. He called it a shell game with mathematics. He knew it worked. He also knew it was ridiculous. And to this day, nobody knows why it works. Nobody knows what we're really doing when we perform these calculations. We're just shuffling symbols around until the answer matches experiments, and we call that understanding. Here's where it gets even stranger. The electromagnetic force, the thing we call electricity, is a billion times stronger than gravity. You read that right. 1 billion to the 4th power. If you take 2 protons, the electrical repulsion between them is a 1 followed by 36 zeros times stronger than their gravitational attraction. That's not a big number. That's an incomprehensible number. It's the difference between an atom and the observable universe. And yet, you don't notice electrical forces pulling you around every second of your life. Why? Because the universe is electrically neutral. Every positive charge is almost perfectly balanced by a negative charge. Almost, not perfectly, just almost. And that tiny imbalance, that minuscule excess or deficit of electrons, creates every electrical phenomenon you've ever experienced. Your heartbeat, your thoughts, the light from your screen, all of it comes from the faintest whisper of imbalance in a force so powerful it would tear reality apart if it weren't carefully cancelled out. Maxwell figured this out in 1865. He was trying to make sense of all the weird experiments with electricity and magnetism that people had been doing for decades. Electric forces, magnetic forces, they seemed completely separate. But Maxwell noticed something. He realized the equations didn't make sense unless he added a new term. A term that nobody had ever measured. A term that said, changing electric fields create magnetic fields, and changing magnetic fields create electric fields. And when he put that term in, suddenly the equations did something shocking. They predicted waves, self-sustaining waves of electric and magnetic fields that could travel through empty space, feeding off each other, propagating outward forever. And when Maxwell calculated the speed of these waves using the measured strength of electrical and magnetic forces, he got an answer. 299,792,458 meters per second. The speed of light, not close to the speed of light. exactly the speed of light. And that's when he realized. Light isn't something separate. Light is electricity. Light is an electromagnetic wave. The thing illuminating this room right now, letting you see these words, is the same force that shocks you when you touch a doorknob. It's all electricity, just vibrating at different frequencies. And then it gets worse. Because Maxwell's equations predict that electromagnetic waves should exist at any frequency, any wavelength, and they do. Radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays, all the same phenomenon, all electromagnetic radiation, all electricity vibrating through space, which means when you listen to the radio, you're detecting electricity. When you warm food in a microwave, you're bombarding it with electricity. When you get a sunburn, electricity is damaging your DNA. When you get an X-ray, electricity is passing through your body. The entire electromagnetic spectrum, from the lowest frequency radio waves to the highest frequency gamma rays, spanning 20 orders of magnitude, is all the same thing, all one force. And we have no idea why it exists, no idea what creates it, no idea what it's made of. We just know it's everywhere, permeating every cubic centimetre of space, and we've learned to manipulate it. Here's what really kept Feynman up at night. When you accelerate an electron, it radiates energy. It creates electromagnetic waves that carry energy away into space, which means accelerating the electron takes more force than you'd expect. There's resistance, extra resistance that comes from the fact that the electron is creating waves, and those waves carry energy. So where does that energy come from? It comes from whatever is pushing the electron. You have to do extra work to accelerate it because it's radiating. That's fine. That makes sense. But here's the problem. Those waves are created by the electron, and those waves are electromagnetic fields. And electromagnetic fields exert forces on charges, including the electron that created them. So the electron is creating waves, and those waves are pushing back on the electron. The electron is exerting a force on itself. And when Feynman tried to calculate this self-force, he got infinity again. The electron shouldn't be able to accelerate at all. It should be completely frozen by its own infinite self-interaction. But obviously, electrons can accelerate. So what's going on? Feynman spent years on this problem. He tried everything. He proposed radical new theories. He imagined that maybe there's no such thing as a field at all. Maybe electrons just push and pull directly on each other across empty space with a time delay. You shake this electron, and a moment later, a distant electron shakes because they're interacting directly without any field in between. It was elegant. It solved the self-force problem. If electrons only interact with other electrons, not with themselves, then there's no infinite self-energy. Problem solved, but it didn't work. When he tried to build a complete theory, it failed. The self-force is real. The radiation is real. The infinity is real. And to this day, nobody has solved it properly. We use the same mathematical tricks. We subtract infinities, we renormalize, we get the right answers. But we don't understand what we're doing. We don't understand why it works. We're performing a ritual, following steps that produce accurate predictions. But the meaning behind those steps remains completely opaque. Here's the thing that should terrify you. Everything you think is solid, everything you think is real, is held together by electrical forces. The chair you're sitting on, the floor beneath your feet, your bones, your skin, every atom in your body, protons and electrons, attracted to each other by electrical force. That force is what stops your hand from passing through the table when you touch it. It's not that the atoms are solid. Atoms are mostly empty space. Electrons are tiny. The nucleus is 10,000 times smaller. If an atom were the size of a football stadium, the nucleus would be a marble at the centre, and the electrons would be specks of dust in the upper seats. The rest is nothing. Empty space. So why doesn't your hand pass through the table? Because when the electrons in your hand get close to the electrons in the table, they repel each other violently, with a force so strong it feels like the table is solid. But it's not solid. It's a force field, an electromagnetic force field. Everything you've ever touched is a force field. You have never actually touched anything in your entire life. You've only ever felt the electrical repulsion between the electrons in your skin and the electrons in other objects. Contact is an illusion. Solidity is an illusion. It's all electricity, all the way down, and somehow we've learned to control it. We've learned to make electrons flow through copper. We've learned to make electromagnetic fields oscillate at specific frequencies. We've learned to encode information in those oscillations. We've learned to send that information across the world at the speed of light. We've built computers, smartphones, GPS satellites, the entire internet, all of it running on a force we don't actually understand, all of it manipulating fields that nobody can explain. We are, right now, is at this very moment, performing what would look like absolute magic to someone from 200 years ago. Invisible forces moving across space. Information transmitted through empty air. Images appearing on glowing screens. And we do it so casually, so thoughtlessly, that we've forgotten how utterly bizarre it is. Feynman realized this. That's why he was never satisfied with his lectures on electricity and magnetism. He said he couldn't think of a really unique way to present it. Not because he didn't understand the math, he invented new math. He revolutionized quantum mechanics. He could calculate anything, but he couldn't explain it. Not in a way that made it feel less weird, not in a way that answered the fundamental question. What is electricity? And the more he tried to answer that question, the more he realized the answer was deeply, profoundly strange. It's not a thing. It's not a substance. It's not particles in a wire. It's a field, an invisible, massless, unexplainable field that fills all of space, that has always filled all of space, that connects every charged particle in the universe to every other charged particle instantaneously through some mechanism we cannot comprehend. And we've learned to twist it, to bend it, to make it dance to our will. Think about what that means. Every time you send a text message, you're causing electrons in your phone to vibrate. Those vibrations create electromagnetic waves. Those waves propagate outward at the speed of light. They hit a cell tower miles away. The tower detects the waves and converts them back into electrical signals. Those signals travel through fiber optic cables as pulses of light, more electromagnetic waves, across thousands of miles. They reach another tower. That tower converts them back into radio waves. Those waves hit another phone. That phone's electrons vibrate in the exact pattern your phone's electrons vibrated, and someone across the planet sees the message you typed, all in under a second. You just reached across continents and manipulated matter you've never seen using a force you don't understand. And you did it without thinking twice. We call this technology, but it's not technology, not really. Technology implies we understand what we're doing, that we've mastered something, but we haven't mastered electricity. We've just learned to poke it in the right ways. We've learned that if we arrange copper in certain patterns, if we vibrate electrons at certain frequencies, if we push fields through space in certain directions, we get useful results. But we don't know why. We don't know what we're actually manipulating. We're like children who discovered that if they press specific buttons on a machine, the machine does cool things. But we have no idea how the machine works. No idea what powers it. No idea who built it. We just know which buttons to press. And here's the part that should really unsettle you. This isn't some fringe topic. This isn't a weird corner of physics that doesn't matter. This is fundamental. This is one of the four forces that govern reality. Gravity, electromagnetism, strong nuclear force, weak nuclear force. Four forces, that's it. That's all there is. And we don't really understand any of them. We have equations that describe what they do. We have theories that predict their behavior, but we have no idea what they are, no idea why they exist, no idea why there are 4 and not 3 or 7, no idea why they have the strengths they have. We're pattern matching. We're saying, look, when we write down these equations and solve them, the answers match what we see. So the equations must be right, but the equations don't explain anything. They just describe. They're maps, not territories, and we've mistaken the map for the territory. Feynman knew this. That's why he spent his entire career trying to dig deeper, trying to find a more fundamental explanation, trying to answer the question everyone ignores. Why? Why does the universe work this way? Why do electromagnetic fields exist? Why do they propagate at the speed of light? Why is the speed of light what it is and not something else? Why can electric fields create magnetic fields and vice versa? Why is the force between charges inverse square? Why are there charges at all? These aren't just philosophical questions. These are the deepest questions in physics. And we have no answers. Zero, we've built nuclear weapons. We've sent probes to the edge of the solar system. We've split atoms and mapped genomes and decoded the structure of space-time. And we still can't answer the most basic question a child might ask. What is electricity? So here's what you need to understand. The next time you flip a light switch, the next time you charge your phone, the next time you use any electrical device, stop for a moment. Really stop. And think about what's happening. You're manipulating a fundamental force of the universe. A force we don't understand. A force we can't explain. A force that has existed since the beginning of time, woven into the fabric of reality itself. And you're bending it to your will, casually, effortlessly, without even realizing the magnitude of what you're doing. You're reaching into the deepest layer of physical reality and making it dance. And you do it so often, so automatically, that it feels normal. But it's not normal. It's not normal at all. It's one of the most profound mysteries in existence. And we live inside it, surrounded by it, made of it. Every atom in your body held together by electrical forces. Every thought in your brain carried by electrical signals. Every sensation you've ever felt transmitted through electrical impulses in your nervous system. You are, at your core, an electrical phenomenon. A pattern of charge moving through space. And you have no idea what that means. Feynman understood this. He understood that the more you learn about electricity, the stranger it becomes. The more you dig into the equations, the more you realize they're describing something utterly alien, something that doesn't make intuitive sense, something that violates every assumption you have about how the world should work. And yet it does work perfectly, with mathematical precision. The universe runs on rules we don't understand, using forces we can't explain, following laws we can describe but not comprehend. And we've gotten so used to it, so comfortable with it, that we've stopped asking why. But the question remains, what is electricity? Not the word, not the definition, not the equations. What is it actually fundamentally, but at the deepest level of reality? And the answer, the honest answer, the answer that kept Feynman awake at night is simple. We don't know. We have never known. And after a century of the most brilliant minds in physics trying to figure it out, we still don't know. We just know it's there. We know it's real. We know we can use it. And we know that using it, understanding it, mastering it, has given us everything we call modern civilization. But we're not masters. We're tinkerers. Playing with forces we barely comprehend, standing on the shoulders of giants who admitted they didn't understand either, and all of it, every wire, every circuit, every device, every technology that runs on electricity is built on a mystery so deep, so fundamental, that the greatest physicist of the 20th century couldn't explain it to a classroom of students, a mystery we live with every single day. A mystery we've learned to ignore. But it's there, always there, humming in the walls, flickering in the lights, pulsing through every device around you, an invisible force that holds the universe together and powers your entire world, and you don't know what it is. Nobody does. That's what Feynman discovered. Not a new equation, not a new theory, but a profound truth. We are manipulating the fundamental forces of reality without understanding what we're actually doing. We are sorcerers who've learned the spells but forgotten the language they're written in. And the universe doesn't care. It just keeps working, following its inexplicable rules, responding to our manipulations with perfect consistency. And we call it electricity, we call it technology, we call it normal. But it's not normal. It never was. It's one of the deepest mysteries in existence. And we've just gotten very, very good at pretending we understand it.